This is a selection of pre-calculus on-ramps question from a worksheet on, I think it's parametric functions. And I need to do, let me check my numbers. I need to do 13, 16, 21 through 26. So let's see. Eliminate the parameter t to write the parametric equation as a Cartesian coordinate. All right, so really what I have here, I could rewrite this just to make it simple on myself. This is x and this is y. X equals 5 minus t, y equals 8 minus 2t. In this case, they're both linear, so I think either one will be pretty simple. I'm just going to solve this one for t. I'm going to add, subtract 5 from both sides. X minus 5 equals negative t. And I'm going to, well, I guess I'd have to do the x one first here because I want to get y equals something. So I do the x one here first. So I get x minus 5 equals minus t. I switch all the signs. This is negative, this is positive, this is positive. T equals negative x plus 5. Now I can substitute that into this second equation. 8, y equals 8 minus 2 times negative x plus 5. I will distribute the negative 2. Y equals 8. Negative 2 times negative x is plus 2x. Negative 2 times positive 5 is minus 10. And then I will add like terms. Negative 10 plus 8 is negative 2. 2x minus 2. And so that would be the Cartesian equation, y equals 2x minus 2. And you would do the x one first because I want to get y equals 2x minus 2. Better to do it that way. Okay, then I have to do, I keep forgetting, 16. This one I'm going to do the linear one first. So I have x, this is y. X equals 3t minus 1. I will add 1 to both sides and divide by 3. X plus 1, and then I divide by 3 equals t. And I could substitute in that for t in this other equation. Y equals 2 times x plus 1 divided by 3 squared. And you can leave it that way, or you can square that 3. So 3 squared is 9. 2 over 9 times x plus 1 squared, which is probably better because this is y equals a times x minus h plus k. That's the vertex form of a parabola equation. Okay, 16, then I have to do 21 through 26. What is this? Same instruction? Rewrite as Cartesian. All right. This one, remember this, that x to the a power to the b power equals x to the a times b power. So in other words, I can factor an exponent and just raise it to that power. So I can rewrite e to the 6t as e to the 2t power times 3, because 3 times 2t is 6t. And now, this is easy. X equals e to the 2t, so I'll substitute that. Y equals, for e to the 2t, I'm putting x, and it's raised to the third power. Y equals x cubed. That's the Cartesian. Okay, this is ridiculous. I keep forgetting. 21 through 26. Here's 22. This again, y equals t to the 9th. I could put y equals t to the third because 3 times 3 is 9. I can multiply those exponents. And so now I substitute x for t to the cubed. Y equals, that's x, and then the cubed on the outside. Y equals x cubed. All right, that's 22. I got to do 23, 24, 25, 26. Okay. This one I'm going to use sine squared t plus cosine squared t equals 1. If it's at secant and tangent, I'd use secant squared t secant squared t minus tangent squared t equals 1. And if it's a circle, I've just got to, it's going to be equals r squared. I just have to divide everything by the r squared so I get it equal to 1 before I convert. All right, so this one, when it's sine and cosine, I could associate the x with the sine or the x with the cosine. It doesn't matter. When it's secant and tangent, I have to associate the x, the first one with the secant and the second one with the tangent. Positive for secant, negative for tangent. So order does matter on those. All right, this one it doesn't. I'm just going to do it just the way I wrote it, or actually, it's the way they've written it. So x equals 4 cosine t. I'm going to divide both sides by 4. X over 4 equals cosine t. And this one I'm going to do y divided by 5 equals sine t. And now I want sine squared plus cosine squared. So x squared, I can put the cosine first if I want. X squared over 4 squared equals, I'm just squaring it. If I square the whole thing, it's x squared over 4 squared. X, why did I put equals? Who knows? Plus, I want to square this one, y squared over 5 squared equals 1. That's an ellipse. That is a vertical ellipse at the center at 0, 0. All right, this one. This is also going to be ellipse, center 0, 0. X, Y. So I'm going to put divide by 4 and subtract 1. X minus 4. I said to subtract 1 and, divide by 4. X minus 1 divided by 4 equals sine of t. And y plus 2, I'm adding 2 and then divided by 7 equals cosine t. Oh, yeah, and these, they give you the order. They tell you which one is sine and cosine. It's on the next one, 25 and 26, that you can make this sine and this cosine, or you can this cosine and that sine. When it's the plus one, it doesn't matter. But when it's the minus one, like these, which I don't think are on my list to do, the positive one has to be secant squared, and the negative one has to be tangent, because it's secant squared minus tangent squared. That's a hyperbola. But anyway, these, they've already, I don't have to worry about which one is which, because they tell me. All right, so I've got x minus 1 over 4 cosine, and then y plus 2 over 7 equals cosine. I square them. X minus 1 squared over 4 squared, I just squared everything, plus y plus 2 squared over 7 squared equals 1. Sine squared plus cosine squared equals 1. And they'll be ellipse with center at 1, negative 2, and it is a vertical ellipse. All right, that is 24. I got 2 more. Now this one, I could put cosine first, like I just said, plus sine squared, or I could put sine squared plus cosine squared. Both are positive, so it doesn't matter. A lot of times in your answer sheet, it'll say answers may vary, or else they'll just give both possible answers. I'm going to use cosine and sine. So this is going to be the cosine part. That's 6 squared, that's 5 squared, just to make it easier. So I'm going to put x minus 2 over 6 equals cosine t, because this is cosine squared, and I just take away the square. So I'm going to multiply both sides by 6, add 2 to both sides, and so I get x of t equals 6 cosine t plus 2. I could have x of t equals 6 sine t plus 2, and then the y would be with the cosine. But I've decided to do it this way. And then it's going to be y plus 3 over 5 equals sine of t. I never leave enough room. So I'm going to put the 5 there, multiply both sides by 5, subtract 3, and I'll just get rid of them there, and I'll just put the y of t. Y of t equals 5 sine t minus 3. Now again, I could have 6 sine t plus 2 and 5 cosine t minus 3. It doesn't matter. Both are positive. So I have to do 28. Is that the last one I have to do? No, 26 is the last one I have to do. All right, this is a circle. So remember, I know that cosine squared plus sine squared, or sine squared plus cosine squared, whichever one you'd like to do, has to equal 1. So I just divide everything by 49. And 49 over 49 equals 1. And 49 happens to be 7 squared. So I'm just going to do sine squared plus cosine squared. You can do cosine squared plus sine squared if you want. So I'll put x plus 3 over 7 equals sine of t. I will multiply by 7, subtract 3, and those go away because I multiplied by 7, I subtracted 3, and I get x of t equals 7 sine 4 minus 3. And then y is going to be y minus 1 over 7 equals cosine. Whoops. I'm going to give myself the room. Cosine t. I multiply by 7, add 1. And there's my answer. I'm just going to repeat it again. I could have x of t equals 7 cosine t minus 3, and y of t equals 7 sine t plus 1. Doesn't matter which way it is because they're both positive. Is that all? That's all I have to do for this worksheet.